So welcome today to our Interspecies Conversations lecture. I'm Kate Armstrong, and I'm head of program at the Interspecies Internet. It's my pleasure to welcome all of you, and on behalf of trustees and organisation, we hope that you enjoy this fascinating talk. So Interspecies Conversations series is a regular online lecture and workshop series that gives the opportunity to leading professors, scientists, researchers, and students to share and present their work that contributes to advancing the acceleration and understanding of the diversity, forms, and functions of communication in other species. We aim to showcase emerging ideas and discoveries and host open discussions where the community can join the conversation. Could I just ask that everybody shuts off their microphone, if that's okay? Okay, so I'm going to introduce our speaker now. Our speaker is Jinger Zeng, and she's going to speak about open hardware communities to empower citizen science. So this talk will be about how open hardware projects and companies can shape the future of sustainability. Over the past 2 decades, open source hardware has leapfrogged, providing accessible tools for citizens to design, build, hack, innovate, collaborate over, customize, and deploy hardware technology. Communities of practice have grown around the technology. In some cases, open hardware is being used as an affordable alternative to sense, monitor, and gather data on non-human animal populations and environments. Jinger Zeng is an ecosystem and community builder and contest manager at Hackster.io, an online platform and community that focuses on open source hardware and electronics projects. As a long-term practitioner in open hardware, Jinger will share her personal experiences and takeaways from building a robotics startup based on open hardware, managing a global developer ecosystem and community to balancing commercial and social approaches in the field. So I will now pass over to Jinger. Please, the floor is yours.
Awesome. Thank you, Kate. And hi, everyone. I am extremely humbled and honored to be here to share this evening or morning, whatever is the time for you around the world. And I truly think, these kind of online virtual events are super amazing in terms of bridging people. And I am here today to really just, to share some of my stories. And then, of course, I think the whole interspecies conversation is really fascinating. And we can then, discuss, based around just some of my perspectives and stories. Again, I'm Jinger Zeng. I'm actually right now in Chengdu, China, where my hometown is. Most of the time, I travel in between US and Bali, Indonesia, where Kate is currently at. And some of my just current involvement, I wear many different hats and have kind of a diverse background, but I think maybe that's why some of my perspective could be interesting to you. So I work at Hackster.io, which is an online community for engineers to learn anything around electronics, hardware. It's an online community, and people post different stories and projects that they work on, to the website itself. And then I run a lot of the curated contest to enable the engagement and skill building. So overall, a very, very fun platform to work at. I'm also on the board of OSHWA, which is the organization called Open Source Hardware Association, that's based in US. It gives a definition for open source hardware. It's a nonprofit, and then also have this certification program for different people that's implementing open hardware. I'm the founding member of Fab Lab Bali, and Fab Lab is a global network of different maker spaces and academy-like programs. Every year, there's an annual conference, for this global network. And Fab Lab Bali actually is one of the newer labs. And I'll go into a little bit story later in terms of like my involvement over there. That's one of what I'm focusing a lot of like my time and energy and passion on currently. And kind of where I'm come from, we'll go through some of these like journeys a little bit, like through my story as well. But I went to born and raised in China, went to US for college. I actually studied mechanical engineering in college. And my master program was actually building a net zero solar home. So that was like the first one down here. That's part of the solar decathlon, and how I really started a lot of my journey in sustainability. And then actually after college, I didn't go like a regular job to become an engineer, and I did a startup. So I did a student startup, which is called Dronesmith Technologies. And then after that, I worked for a Swiss startup called Alterian, and then a US nonprofit called Drone Code Foundation, which we'll go through kind of like in my first story. So yeah, I'm really here today to share these. I kind of segmented like the this sharing session into like 3 stories on just how open hardware and community help shape myself, and also just my perspective and why this would be something of interesting to this community. And also I just feel like it's also very impactful to the world we are living in right now. As I said, really the first story I call it the drone girl. That's what a lot of people actually in the professional world kind of refer me as. And it's in my early journey when I was transitioning from being a student into the professional world. That's what I did, and we took a student engineering project into a startup on drones, and this was back in 2014. So drones was still like a pretty new concept and new technology back then. In terms of in the commercial world, most of the drone at that time, it's a very military based, very expensive. So what we actually really shoot out to do is to build these very versatile like research drones that's available for developers. And that's how I actually fall into the open source hardware world. Even like during my engineering college days, like open source, or like open source hardware, how this work were never in our curriculum. We've never even heard of like these words. But at the time, as it was just very much that we wanted to create this product that's low cost and that's available for other students like us, other researchers like us to be able to afford it. So we, as kind of like an early, very young student startup, we found out, okay, we can design this PCB to fly the drone, and then there's this open source project from ETH Zurich that's across the world that's free code, on the internet that we can use. So so that actually shaped out our very early first products, which is a flight controller that has also IoT capability, Wi-Fi capability. So all of a sudden, like your drone, instead of just a flying, like flying 4 propellers type of thing, you could add software on top of it. You can program it from remotely. It become a IoT device. And just very easy, accessible, and you're able to add on. It opened up a whole door of how interfaces are built and designed. So we set out, actually our company at the time, we named it Dronesmith, so for people who build drones. And then of course, like kind of in the startup journey, we went through like Kickstarter, and then we went to start going to like Maker Faire, and there's a lot of maker that really liked just it being low cost, and also just fully hackable, and being open, programmable, all these features and at the time for $420, it was just phenomenal in terms of its price range. So this kind of approach, at the time, I don't think we really called it open hardware ourselves. It's more of just our mission of really trying to give more accessible tools for people to interact, to build on top of this innovation, to make it more accessible for developers. So, and actually what ended up happening as we were building the company, this whole PX4, the open source software ecosystem, also is like flourishing all over the world. The founder of PX4, he actually open sourced 4 different components of like the whole drone sectors, including the communications protocol for the drone, the SDK, which is a software development kit for the drone, and as well as the ground control software for the drone, and all in open source software format. And then a lot of and the founder actually at that time, he was just a PhD student at ETH Zurich. So not having a company, not have like resources of engineers, like a big company like DJI would, but he's able to use this kind of collaborative framework, build out a whole global ecosystem. So manufacturers in China like picked up, hey, I have free code that's on the internet, and and China's really good at hardware design. So a lot of like smaller actually Chinese hardware manufacturers start adopting and also came into the ecosystem to produce these flight controllers. So over probably like the between 2000 between there was like about 8 years of like the growth here. Big companies like Intel was investing into this ecosystem, Intel, Qualcomm, anywhere from chip level supporters all the way up to software developers, hardware manufacturers, were all collaborating in this ecosystem. And so to this day, if you go to PX4's GitHub, the code is written is contributed and co-created by over 500 different developers from around the world. And there's, still very active pull requests, issue listing, all these kind of collaboration going on in the project. So, and how I kind of transition in that was that, my startup actually, I closed down, I moved back to China. There was a lot of transition, like in the 2016 and 17 type of time frame. But because I was in this open source community, so as soon as I landed in China, and then I got another like drone consulting project, went on that I did some like consulting. But eventually where that led me, and since I was very uniquely positioned between China and have the US background, I end up being the global community manager for PX4. And in the days when I was the community manager, we hosted, I helped started the first global developer conference, in-person conference in Zurich. We created roadshow to really evangelize how to use the software, how different hardware companies can all build based upon this open hardware methodology to enable their own drone businesses, and also just evangelizing, how to even work in this collaborative type of framework, because again, it's very new. it's very different than the DJI kind of closed source approach where you buy a product. So the software is co-created by a global developer community, and anybody can contribute. But there's also maintenance, there's like feature requests, a lot of these different dynamic that's even beyond developer, because there's also the different culture of understanding of open source that just become very interesting. So I also helped push PixHawk it as its own product towards the first kind of open hardware standard. So we saw there was like a lot of different different drone hardware that was being created from the open source approach. But then what ended up happening, like through, and this is like more like 10 years after the project was open sourced, it got adopted by all over the world. And then we start actually saw the need of creating standardization around certain aspects of the hardware, so that we have interoperability in the ecosystem. So till this day, if most people know DJI, but if you look at the drone world, there's a lot of many more commercial drone that's very versatile in terms of the complexity of its airframe. That's actually powered by PX4. Anywhere ranging from things that have 4 propellers, that's called multicopter, to fixed wings, to vertical takeoff and landing. All sorts of these different drones, and they all exist because of the open hardware approach. And also it enables a lot of the local build. So things, like this Tanzania, like a bamboo drone, the creator were able to just curate the core components of the hardware and then build out a frame that's based on his local material and still do the same thing that a drone would do in terms of mission, in terms of applications. So really the big takeaway, and again, this is based off the OSHWA definition, like why open source hardware is a viable thing, and it's why it's important, as a piece of the way people develop technology, is that kind of open exchange, and it really reduces the cost, of R&D. I think if a PixHawk, or a PX4, if it wasn't for the open source approach, Lorenz now has his own company after he graduated, with his PhD, but it would never probably get to the scale. And it actually got to the scale probably on a much lower budget and with kind of pooling of money from all sorts of different companies in its journey to really create that kind of a sustainable ecosystem. So now we call it vendor neutral, but overall, like PX4 belongs to, all the different platforms that uses it, and gives it quite some resilience in terms of like the need to keep sustaining it on the global level. So that's kind of like my story 1, and my story 2 goes in, I call it from a scrappy entrepreneur to a taste of citizen scientist in 24 hours, and this was a really again, it's a 24-hour story, but the reason why I want to tell this story, because it's another kind of life-changing moment for me, that I transitioned from this engineer entrepreneur to, like I said, get a taste of, what it means to be a citizen scientist. I think when I was growing up, like we all at one point in time, it was like, oh, I want to be a scientist, I want to go to MIT. But throughout the years, probably that never come back to me. And so Manu Prakash, he is one of the trailblazer fellow in open hardware inside in one of the OSHWA program that I'm very much involved in. So last year in the Fab Network, we hosted the annual conference, which is called Bali Fab Fest in Bali. And I really, to join the contest at that time was I was just trying to chase him. So because he wasn't replying to our email, and we need to talk to Manu and to give him this award. And so this was a very magical experience for me. Manu is a professor from Stanford, and he's an inventor of this $1 microscope called photoscope. A biologist, he helped come up with the instrument that detects malaria. And overall, is just a super wonderful human. And I still remember till this day was probably one of the last day of the festival. Manu's, doing like a biodiversity talk on and overall in general, like his work. Because also one of the theme of the conference was the biodiversity of Indonesia, and it has so much biodiversity, but there's not enough scientists, to really document, to classify. So how do we really get more of these scientific data? How do we train more scientists in this area, so we can really get to understand our world, and even just this side of the world. There's 17,000 islands in Indonesia, right? That's just untapped potential in terms of knowledge. How do we do that? So the talk was a little bit around that. And then the next thing I know, I actually, like after Manu's talk, Manu also, was hosting a Fab Island challenge with some local students that to do this research, and I asked to join. So the next thing I know, I'm on this van, like with all these people I just met, to go do research. And so this is, some of the beautiful scenery in Bali. And then this is kind of my face is like, where am I? This is actually a Med beach. Just like 4 hours later, I'm here at the beach. I'm in like this boat that I've never seen in my life before, with this like local fisherman, and we're about to go out to the ocean to take plankton samples, right? Like I think at that time it's like maybe I didn't even know what plankton like at the time I think it was, just because of like my shallow type of like biology was like never a subject I ever like. And again, the next thing, like this is around probably sunset time. We are in the ocean with the local fishermen and doing science research. We're taking samples of like the plankton with some like local materials that these students just built in the last like 3 days. And then let's see. And then when we get back to the ocean, then this is, you can see it is already dark. We're looking at these micrograms events. So we also see like the ocean, illuminated. That's the first time I saw like bioluminescence. So we took the sample and literally right at the ocean, and Manu was, using his photoscope and his phone to look at these microorganisms. And that to me was so shocking in the way science is done. I think I've always had this imagination of it's like a very elaborate process. You wear these like white coats in the lab, but the reality is like, all these like this type of field research, especially marine biology, plankton, you can't take the sample back to Stanford, right? And to do the research over there. So it needs to be field oriented. It needs to be frugal, and also needs to be low cost. It needs to be has all these agility, and surprisingly, so in this whole crew, Manu is the only scientist. Everybody else is like newbies. So rookies, however we call it. And so this is Elaine and Victor in here. They're both Indonesian. Literally just also joined the Fab Fest. So Manu trained everybody, like also from just like 5 days before this whole thing happens. Set up a whole lab where it's now the Fab Lab body, with these low cost put together modular scientific instrument. And if you see over here on the very right-hand side here, that Plankton was probably, he was telling us, oh, you guys are probably discovering some of like the first, by human eyes, in terms of, that kind of like species in the world. So, that was the 24-hour. That was a 24-hour that I experienced, as kind of just, got into this open science things. So there are some like components I was super familiar with in terms of like Arduino, Raspberry Pi. So if you talk to some of like the open hardware people, those are the names they resonate with in terms of just the brand names, the very powerful but single board computer that allows people to program and do different things. So next day continues. We go out to a different beach. We collaborate with a fisherman. We actually, since this $1 microscope, it's just so easy and accessible. So we were also giving it like to the fishermen. It's like, you should take this back to your kid and have him look through it. And they were just like, it was shocking again, in terms of just putting a piece of science instrument into like a really regular person's hand, and how that just provokes curiosity. So so that was Photoscope, the one that you saw. But also there's this more sophisticated one right now. It's an open hardware project called Planktoscope. And so just like in the definition before, in terms of open hardware, it's really easy. So the key thing is that you can build it yourself. You can build it anywhere in the world by having the access of the documentation, of the reference design, and all these components. You should be able to like source it yourself. So that whole open and accessibility enables anyone who's interested, if you have the drive, if you have the passion, to be able to participate, but also contribute. So this type of open hardware approach really enables anyone from around the world to be a citizen of science, instead of, let's say, anyone needs to, like be able to get into college. So like I said, many of the since that kind of story, a lot of like many students, they were actually designer background or architect background, and now totally got immersed in this whole science and marine biology type of thing, where they might not back then, have access to go into a science, to go into a STEM engineering program in college. So so now we do a lot of these like a grassroots kind of citizen scientist projects at Fab Lab Bali. And of course, this is also a gallery of the different planktoscope that you can see that's built around the world. And these are just some of the ones that's documented, that's being shared by the community. But the very, very similar type of ethos, the microcosmo is also a community, a global community, where people, after they use Photoscope and able to see the sample or whatever they're seeing through the microscope, they can use the app to upload that image and geotag it, and then post it to the Microcosmos website. So now anybody who goes to that website can see and then geotag, like different species from all around the world. So, and on Hackster, and I mentioned Hackster is more of like the website for engineers. We've seen, another kind of level, and this is what happens when it's open and it's accessible, in terms of adding TinyML on top of this. So for those of you who are not interested, who are not familiar with the word TinyML, it basically is like micro machine learning. So it's like artificial intelligence on the chip, or on the device itself, so that you can do classification, like all these identification algorithm through directly on the device, let's say through one of these like mini cameras. So then we start seeing, oh, then these engineers, because I think most of the people who are in the kind of microscope community are more like biologists, and then you'll see kind of embedded electrical engineer kind of community to come in and also put on top their innovation of what they can do, to add on to the capability. And these are all the power of being in a very collaborative and open kind of tool with the toolings, and the community. So that was very interesting. So like on this project, you'll see here the hardware components as Photoscope and the OpenMV Cam M7. The OpenMV Cam, I believe, is only like $8. So it's an $8 camera, or something that's of like that very low cost and also just open algorithm as well. It's actually also maintained or invented by a friend of mine, the Kabana. So with these kind of like low cost accessible accessories, anybody from around the world, can really, as we said, become a citizen science and contribute, and really just help us unlock more of like the knowledge we have in the in our world. So so that's kind of like my second story. Now my third story, this very much tie into a collaborative, like one of my long-term partner, friend, company that's based in Shenzhen called Seed Studio. And Seed Studio, they are the creator, they are the maker of a lot of these low-cost open hardware. They are one of like the contributor in terms of like the early maker movement, and they still strive to this day to create products around, we said, making sense of the wild. And so you see, I think it's very interesting where we are living in right now in terms of we're taking things from offline to online. Online meaning, let's say, platform like Hackster that showcases all these different innovations from around the world, and then from online to offline, because people then, let's say, across the globe, after they share the story, they can reference that and then take it into some context and implement it in their local context. So the during the Hackster online contest, which is called IoT into the Wild, which we ran last year, it was about a 3 to 4 month. I think it was about 4-month contest across the globe. We had over nearly 600 participants, and I think we had about 120 eventual full documented open source tutorials that I'll share some of those here in the next few slides, in terms of just how different people from around the world use these sensors and the hardware to tackle the making sense of the wild and sustainability, conservation, and there's a couple of different themes, and one of them is directly towards biodiversity. So how Hackster contests run is that people can apply actually. So we set up this kind of agreement with Seed Studio, and Seed Studio they give out 100 pieces of these hardware, and then Hackster arranged the global distribution. Actually, at that time, I think Seed Studio did. Anyways, the so the kit itself, I think right here is, I forgot exactly the price for this, but I think it was somewhere around like 20, maybe like $20 to $30, something that's really really low cost. So but it has all the capability for people to prototype a application based on these sensors. So it also have the AI vision capability, has IoT capabilities. So that we often do these kind of like hardware giveaway and send it to all over the world, so that and then have so enable people to build their projects. This is actually Hackster's kind of bread and butter. So the whole goal is that to make things just accessible and give people the platform to exchange knowledge, to showcase their project, to really evangelize their ideas and their awesome inventions. So since this is kind of like interspecies talk, I just curated some of the amazing projects, winning projects from the contest. You can definitely go to Hackster to look at all of the other projects. And like I said, they're all very amazing. But this one is actually from Tanzania about Black soldier flying flies. And then, again, there's different sensor technology implemented, and then to eventually help these young scientists understand, the how to do the feeding. And then this one is actually from Indonesia about kind of monitoring the mosquito growth outside of like sewer line. So to also protect, the local environment. This one was from penguins. So this one's from New Zealand, Australia, I think South Coast, and they're trying to they also build out a whole prototype system to help understanding the migration, and in terms of helping with the conservation and efforts for these really cute pies. And then I think this one is from I think around Argentina, from South Africa, in terms of also again help monitoring the tortoises, that was very hard to actually track, without these devices. And then this one, I don't think this one's under the contest, but it's one of my favorite one from Seed Studios applications, because this one is a live stream pig farm, I think from the Netherlands, where the whole pig farms, it's live streamed, but also they had all these sensors, so it's a smart farm. And then they even had like audio capability in terms of monitoring the health of the pigs, for predictive maintenance, or like if let's say sometimes I heard like if the mom pig is not careful, it might like sleep on top of like the baby pigs, and then they sort of can die. But with a lot of like the audio capability, the audio feedback, that they're able to provide these health monitoring systems, for pigs. And also, of course, there's also our special pandas. So, and actually, Eric Pan, who's the CEO of the Seed Studio, he's from Sichuan. Sichuan's the hometown of the panda bear. Their whole team deployed a vision tracking system, for wild panda in the conservation area. So all of these, are low cost hardware that uses like LoRa, like uses these communications protocol to have to be able to be deployed in the wild, but at the same time send back data, to a base station so that we can get access to the world. I personally think, that's a wonderful invention, kind of like currently, in terms of just how we now have the tools to really get the data, really understand more of the different species that live around the world. This one's another Hackster contest. It's called Elephant Edge. This one's specific to elephant, and it's actually the contest here is actually driven by Microsoft. It was called Project 15 under Microsoft, but then because Microsoft also made it open source, and like I mentioned before, for being open source, it allows for different other parties to come in and contribute and participate and collaborate. And also being open source gives the longevity of, like, let's say if when one of the partner maybe like is not contributing to the open source project anymore, all the rest can still continue on the IP of it. And that's actually what happened, with Microsoft, because Microsoft, I think, pulled out of like this project. But then, the project 15 lives on because it's open source, and everything still exists, on Hackster and also on Microsoft's GitHub. So, but at that time, what the contest was about was that there are these like different data sets, and there's, these, but how to leverage the brains of all the different innovators and engineers from around the world, and if they can build something that's useful for the development, because not everyone can go to Africa, but we do have the data sets that's already live and available. So what we had asked the innovators, the Hackster community to do is to build out tracking system and dashboard for these hardware tracker. And you can see, so these are elephant colors, and these elephant colors, they have these communications capability, and then how by adding more on top of that, through like maybe like a camera, it really gives a lot more insights in terms of how these animals are migrating, or how they live their life, and how and without kind of like disturbance to them. And another very important thing is anti-poaching, so that it also protects them in terms of all the illegal activities around them. So those are the three stories. Maybe it's like more than three stories, but the three big pieces that I want to share with everyone here. And I have a couple, like I always do this like final thoughts. And this one is, I put it as and we can talk about this later, but it's actually a slide I stole from one of the PhD students that I collaborated with on one of the contests. And so I call this a very PhD takeaway. But overall, like his whole thesis, and this is a kind of a knowledge creation type of a very academia way of looking at things, is that the things that we know sometimes are we are not able to express it all. So the whole knowledge creation, they call it the knowledge creation like spiral, is by a lot of socialization, and externalization, but in other words, collaboration. So the more collaborative things are, the more open it is, the more we can actually unlock a lot of the what they call the tacit knowledge, which we might not even know that exists there. So that's so this, I put it really here because this goes into some of like my work in terms of the Hackster. How do we create an even more collaborative environment for the global online community to create more innovation, right? So there's the other kind of like theory in terms of like the reason why also there's a lot of product development method right now that might be outdated, because it's not this kind of socialization approach. It was very consulting type of, just survey things and asking things in a very like structured way that is actually hindering innovation. So, but by actually a more human, like social interaction, it creates more. But the gist of this is that really, I think why we're talking about open hardware here, and how this fits into the interspecies kind of things and why it applies, is because we've seen it in drones, which was my first story. We've seen it in kind of like the other aspects of what Manu did, with his project that's global impact, global wise, is that when you lower the barrier of entry, which is bring down the cost. You open it up so it's not closed up, it's not proprietary. You increase the participation. And the more you increase the participation, and goes back to the last slide of like the knowledge creation, there's more innovation that can be unlocked. And then it also reaches scalability, which is, I think, in the world we're living right now, why we care about citizen scientists, because we need more science. We need more science, and to help us solve some of the most pressing things in the world, whether, like that's climate change or all these kind of interspecies, understanding them, and these global scale problems. So part of being frugal and bringing the hardware costs down. So a lot of those knowledge is not just locked within a very elite group of people, is very important, I think, for our time right now. And I'm gonna end kind of my sharing here today with a very Bali philosophy, which is in Bali called the Trihita Karana, and it's the whole harmony, with three pieces of harmony, and of how the world should operate, which is harmony with God, harmony with people, and harmony with nature. This was actually kind of like the etho, or I want to say that the theme around last year's G20, which again, we got a chance to participate from Manu's citizen science project, for the ocean marine biology type of thing. And again, at that time, I think we really impressed that G20 panel because when we presented, we're not even scientists, right? It was actually Manu's students that I introduced in presenting what we could do with local fishermen, with enabling science just across our population, rather than just ministry, like handling some sort of like very research, and then the report, gets put away, in some cabinet. So at that time, like we also very much, I think right now when we're building up Fab Lab Bali, this piece of philosophy, I think is very beautiful. So we really want to also implement that in all the things that we do, for the projects that we take on, in terms, a lot of it goes towards, how to create harmony, with the environment, with the different species, around the world, around different communities, different local communities. And part of that is, I mean, there's different ways of saying it. Frugal science is one. I think open science another one. Open hardware, also fits into this. But all of these, I think, to also create technology, not just for the technology's sake, but in the end, all of these are tools for us to be more in harmony with the nature, with the earth. I think that's where sustainability should be heading towards. So that's kind of my final thoughts, and thank you so much for listening in.
Thank you, Jinger. Lots of reactions to that final note about the ethos that you're working on in Fab Lab Bali. I think that that's something that this community really takes strongly. Many of us are here also because we believe that conservation is crucial to the future of our planet, and I think you really showed a new way for many of us to see this. And I hope, I have a little bit of a background in this field, so I was up there with some of the technical terminology, and I hope everybody was keeping up in this. But I think that you did a great job of explaining all of the ins and outs of what citizen science, open source hardware, global communities can actually do for this field. So thank you so much, Jinger. I really appreciate. Vint is dropping off, but thanks for joining us, Vint. That was great to have you, one of our trustees, Vint Cerf, joining us today. So Yeah, I think we can have some questions. I know a few people had to drop off early, but I would love to hear if anyone has any questions. There was one thing I wanted to bring a comment about, how you fund these kinds of things. Is this a self-funded venture on the behalf of these people who are contributing online? How does it work in terms of contributions in the open hardware community usually? Can you clarify this for us? And then while everybody thinks about their questions.
Oh, sorry, was that a
Yeah,
question
like
for
how
me?
does it, yeah, sorry, Jinger, I'll rephrase it.
I was like reading the comments. Yeah.
Yeah, I was just going to pick up on this one comment about funding. So, are people who are contributing to these, online spaces, are these people who are funding themselves? Are they funded by organizations? How does it usually work? Because I think this is often something when we say open source hardware, non-proprietary, that people get a bit surprised about, because we have different value exchange mechanisms inside these communities. So do you want to give a quick overview of some of your experiences on this while everybody thinks of their questions?
Yeah, totally. I think this is always a very tricky and very kind of complex question. I got this question so much when I was working as the community manager in PX4. Because the interesting dynamic over there was that all the manufacturers in China who actually sells the hardware are the ones that's like making the money from the actual hardware pieces, and then and then the software developers do get paid like more on like a consulting level, this kind of dynamic, but I think it's I don't think there's actually a more like an answer to it, because it's often let's say if you're a researcher, you need to write grants, like for our lab, we do a lot of write a lot of like a grant proposal in terms to support the work, when I was doing startup, and I think that maybe that's why a lot of people really likes to do like tech startup nowadays, like I fundraise through investors, right? So that's another kind of startup entrepreneurship type of totally different funding arena. And that's why, the part of my story was that like scrappy entrepreneur in terms of, like went to school for engineering, but actually came out of school, like have to learn all these trades in terms of investor relations, have to all the others kind of stuff. But that's that's kind of like a side story. So I think it depends on actually who you are, like in that ecosystem. The funding is it's all different, and but in the end, it's I think most important thing is just have a sustainable and a financial model that makes sense.
Yeah, I think the answer is it's just so varied, but depends, what your project is and where you're situated and how you're working. But a lot of these people who are working on, let's say, contributing GitHub, these kinds of places, a lot of this is done through their own will and want to do so. So this is also an important point to make is, a lot of people are contributing because they want to be citizen scientists. So I think that's very important. We have a few questions for you, Jinger. Would everybody like to ask their own question? You're welcome to use the hand up button at the bottom of the screen if you would like to. We have one from Pramod. If you would not like to ask it, I can also do that for you.
I think someone has a question here on how can we contribute to the movement citizen science as a maker and where to start, and if I have tips to share. So different citizen science, like there's always some sort of like a project, right? And then so I'll use actually this one maybe as a good example. I think first of all, you need to find one that resonates with what you care about. Let me see, my screen share is paused. Oh, I want to share this one real quick, Chrome. Oops. Can you still see my screen?
We just see that you've started screen sharing, but we don't see the content.
I don't know why, but maybe I'll just like post the link.
Yeah, paste it in the chat maybe.
Yeah. Oh. So one of my new kind of favorite citizen science project that's very maker oriented. Let me see if I can share my screen now. It's this one called Ribbit Network. So it's literally building this like frog sensor on like, and then you deploy around the world, and because it's deployed around the world, you know, like it collects like CO2 sensor data, and then but this like little thingy. So this is like very maker oriented, you know, you get to do like 3D printing, you know, you get to program like this sensor type of thing. But each of the citizen science project like this one, they will always have something like how you can contribute. Usually it's always, you know, you join the community, and then you find where the status, you know, of the project is. So let's say for this Ribbon Network, we also actually have a hub for them on Hackster. They will maybe looking for on technical wise, they usually like have a roadmap, and then it will say, oh, we're looking for somebody to build out this feature. And so like we see like over here, so they will give you kind of the area where you could contribute to. So whether that's technical wise, whether that's you know, community wise. So Hackster is a good way a lot of times like this resource, but usually they'll have some community guidelines as well. Very similar to the Planktoscope project, right? You know, the first thing is always, well, you need to build the stuff on your own first, but then join the community. There's always a community, so you can communicate with each other, share knowledge across, and different, of course, you know, all the different projects, they will all have, you know, their call to, you know, wherever that forum is, whether it's through Discord or Slack. But yeah, like I think find one that fits your passion and start building.
Awesome. I think that's the takeaway. Start building, right? Just start and see what happens. You know, a lot of these communities also use this spiral innovation technique. So it's just doing, prototyping, trying it out, seeing what happens. We have a question from Darcy. Darcy, would you like to ask this question, or I can also do that?
Well,
would you like to read? So the question is that Darcy's been looking for an audio mock for a while and hasn't had any luck in finding one. Is there other options for recording sound in the ranges outside of human hearing? We also have Violet and Lily from Seed Studio in the house, so maybe they also have some ideas here, or anyone else who has some ideas on this piece of tech. Any other thoughts? Oh yeah, Salman actually gave one example in the chat. Any other question? Any other thoughts on this one? We do have one from an example that came from Salman, who suggests a digital PDM microphone. So maybe this can help Darcy. But Darcy, the other thing is you could ask this in the Slack, the Interspecies Internet Slack, because sometimes people might already have another piece of hardware that they could suggest for you. So that could be useful. Yeah. So the other question we have is from Kelvin in Nigeria, and he's asking about how he can build a software app. Any thoughts here, Ginger?
How to build a software app? What kind of software app? That's a pretty broad question. what kind of software app? And I mean, the first thing, I think you can learn coding yourself, or find a local software developer. But you need to define like what kind of like software app first, and yeah, and there's a lot of templates, open source ones, that's online, that people can learn, to build basic ones. But yeah, more complicated ones definitely need like some software developers on board.
Awesome. So yeah, Violet, thank you for also answering this question. So I think in general, Ginger, also that comment really highlights the fact that a lot of these projects are not actually solo projects. So what you're doing is bringing this really disciplinary group of people together online, often in an online space, in order to bring those skills together. So it may be somebody who has an idea that then is able to then bring, for example, a software developer together with a hardware developer with other kinds of profiles. Is this usually how it works?
Yeah, and another thing, what I personally really like to do is I like to go to hackathons, and I like to look for hackathons. So usually if like if your local place have these opportunity of hackathons, there's lots of different people with like diverse talents and skill sets that could be like of what you're looking for, and then you can always just pitch them what you're working on, and see if they are interested in what you're working on, and perhaps contribute.
Yeah, go ahead.
Hello, I have a comment, please. Hello, Jing, I have a comment.
Yeah, we can hear you. Go ahead.
Okay, good afternoon once again. I know though it's afternoon here in Nigeria, my time is 11 minutes past 4 p.m. So it's afternoon here in Nigeria. Please, my comment is that I so much enjoy this particular session. I mean, it's an opportunity for me to share knowledge and also have more knowledge about the software and the hardware and how to build those things in order to enhance my idea on creativity. So I so much appreciate the host of this meeting today. And Kate, I like the way you talk, and Jinger Zeng, my very good friend so far. I am so much interested to share this very session with you guys. Thank you all.
Thank you for joining us. It's really great to have you. I think, yeah, we have other people. I'm just going to mute you because you're quite noisy. Sorry, I'm just muting you because you're quite noisy in the background, but it's awesome to have you joining. And I think we have some other people in the same time zone, but completely different locations. So that is the amazing thing about this community that comes together globally. So awesome. Thank you so much for joining us. Are there any other questions in the house that we have before we start to wrap it up? I know, thank you, Ronnie, for sharing the wildlife acoustics link. That's fantastic. If anyone else has any other links to share, which I actually do as well, because I work also in the Fab Lab community. So I popped there the Fab Labs IO link if anyone's interested to get in touch with people who are working on these kinds of topics globally. This is also where Neil Gershenfeld, one of our trustees, comes from. So he's leading this from the Center of Bits and Atoms at MIT. So we have great projects coming out of that community as well. So I think maybe on the Slack, we can share any other open hardware projects that are working on this interspecies collaboration. And we're hoping that next session, we will also have a further conversation around similar topics from one of our researchers in our community. So this should be able to continue that discussion. So if you're not in the Slack already, make sure that you join and join the conversation. and hopefully we can get some cross-pollination of ideas there. Any other final questions before we jump off? Kerry, I see you. Yeah, hi. Hey, Kerry.
Hey, thank you. Yeah, just a total rookie question. How do I join the Slack? How do I find you guys on Slack?
Yeah, I'll put the link in the chat now, and you can join directly. We have a quick question from Christian. Christian, do you want to ask a question? I don't know if you want to ask this out loud, or we can also read it out loud. Go ahead.
Be very willing. Okay. Good evening, everyone. I'm Christian, senior student from the Philippines. So I would just like to ask, what skills and basic knowledge would you suggest that we develop or focus on when it comes to starting out in the use of open source hardware? Especially right now, I'm specializing on the development of drone swarm systems when it comes to surveillance applications, and sometimes currently available documentations might be overwhelming. So,
Thanks, Christian. I'll just repeat it because there was some interference with your microphone just slightly. So I'm just going to read quickly the question. So what skills and basic knowledge would you suggest that we develop or focus on when it comes to starting out in the use of open source hardware? What basic path for planning of drone swarms, for wildlife surveillance? In particular, he's also interested in what forums and documentations could be a little less overwhelming for a starter. So where is a good place to go for that? Thanks, Christian.
Yeah, I totally echo that sentiment in terms of overwhelming in term when it comes to documentation and kind of like where to start. For me, for me personally, I actually a lot of times start with literature review. So I go for like a research paper and what are some like the very like you get like the good academia outcomes, and then definitely participating in the online community, always don't be afraid to post rookie questions, like there's always people that's very helpful in these kind of online communities, and being type of like more specific about the, like where exactly the blocker is, or how you want to try to, tackle or framework like the problem, so that you're also well understood, like, and in these kind of like online forum type of like communications. Yeah, but in terms of drone swarms, there's plenty of like research paper around that might be, what's overwhelming you. And but again, like for drone wise, I always go to PX4. That's there's an online community there, and look at and PX4 now, like it's putting out a lot of like really good technical content in terms of how to do different stuff, including drone swarms, and then just start really playing around, with the hardware and the software. Most of the knowledge is really gonna come through you playing with, like the tinkering. For drone, you can even do like simulation. So like simulation, because, like a lot of time I also know with drone swarms, it's like, you don't have that many hardware, right? If you need to swarm 10 drones, you need to buy 10 drones. But, so the real way, now it's in development is like all simulation. So you could, go to ROS, actually, Gazebo, some of those like simulation software, and just deploy 10 drones and see if your algorithm works.
That sounds really fun. I think we all want to go and do that, do drone simulations. I think that sounds very fun. Christian, I hope that helped answer your question. I think that was a pretty comprehensive answer for you. Any other questions before I close? Yeah, awesome. Yeah, thank you so much, Ginger, from Christian in the chat. That's awesome. So I'm gonna do a final call, final round for questions. As I said, please keep going, or keep the conversation going, sorry, in the Slack. I think Jinger is a member of the Slack, and if she's not, she's going to join so she can answer any additional questions everybody has. And of course, if you do need to, if you would like the copy of the chat from today, I can also send that through to anybody who would like, so you can contact me for that. I think other than that, we can wrap it up. Everyone can get on with their mornings, afternoons, and nights. Thank you so much for joining us today. And Jinger, it's an absolute pleasure to have you here. And thank you on behalf of the organization and the trustees. I hope that everyone is inspired to go and start making. I think that was Ginger's advice. Just go and start doing it. See what you can do, join a project, get involved with mapping or sensing your environment and see where it gets to. And please, if anybody has any additional projects to share, let's start sharing them so we can scale up the citizen science amongst our community. So thank you very much, and I hope you all have an inspired weekend. We'll see you soon.